a recipe. So that this is degrees, this is minutes, and this is seconds. Hopefully you saw that in class. The formula is degrees plus minutes divided by 60 plus seconds divided by 60 squared. So you just grab your calculator if you've got one. If you don't, I'll do it for you. But you're just remembering this formula for the exam. You might get one question like this on there. I think there was a time when this was useful, but not anymore.
There's a function on the
Oh yeah, that's right.
to do it.
Yes. This is showing your work if you needed to.
Yeah.
As if you couldn't do it without it. But that is it. I mean, it's there's nothing more to it, but you do need to know how to do it because it probably will come up on a test quiz or whatnot. So 8 is going the other direction. It's saying if I give you 99.37 degrees, we're going to convert this to degrees, minutes, and seconds. So the degrees in this case, it's 99 degrees. So you subtract out the 99 and you're left over with 0.37. To get the minutes, you multiply this number by 60. So 0.37 times 60 is 22.2. And that's the 22 minutes. That's your next number in this exchange here. Let me just insert a little more space in here. Didn't take it. There it is. Okay, so then you subtract 22, or you subtract whatever that number is. You just want the decimal part, and then you multiply it by 60 again. So you take that 0.2 or whatever it is, and you take it all. If there's a bunch of decimal places, and then this equals 12. That's the 12 seconds.
Okay.
You might see. Okay, and then so 16 is next. Lovely. So more of these conversions here. 16 is to convert from degrees, minutes, seconds to radians. Okay, so to do this, you're generally going to be working in, for now you're in degrees, and then you're going to be going to radians. And it's saying convert this DMS first into degrees. So to do that, we did the same thing we did in that previous problem, 75 plus 30 over 60. So it ends up being 75.5 degrees. To convert from degrees to radians, you multiply by pi over 180. To go from radians to degrees, because you will be asked to do that, you multiply by 180 over pi.
Okay.
So in this problem, you're going to multiply this number by pi over 180. And then normally you're given a nice degree, like you're given 30 degrees or something, where it works out nice. Here, I don't really know how you're supposed to write your final answer, but if you do the part without the pi in your calculator and you divide 75.5 by 180 and you convert it to a fraction, I think you get well, no, you don't. You end up getting 151 over 360 pi, or 0.4194 radians. Either are correct. Whatever, kind of whatever you prefer there. Okay. Next question is 24. Is that right? 24? 24. Yeah. Okay. Convert from radians to degrees. So this picture I showed you here, it'll become second nature to you, but you want to remember that. So it's 24 is 1.3 radians. It's important to write that. So you convert that to degrees by multiplying by 180 over pi. And this one, it doesn't say it, but they are looking for a decimal when you do this. Okay. 1.3 times 180 over pi.
It's just 234.
I get
And then do I just divide that?
Yes,
by
yes,
that?
yes. You do want to divide that. So you get about 74.5-ish degrees,
Yeah.
somewhere around there. Okay, so now we're doing 25 through 32,
Okay.
all of these. Okay. I see. Okay, we're going to do 25 and 26 first. So there's a formula. There's a formula here for this, and it comes from the circle here. So let's say you had a nice circle. You have a radius there. You have a radius there. That's your theta. And this is S. S equals R theta. You probably saw that in class. There's a big caveat here, but theta is in radians. So they've been kind enough in the first two problems. Sorry, this is S, R, and theta. They've been kind enough in the first two problems to give you R and theta. So S in the first problem in 25 is 50. As you multiply those, you do need a length to go along with it. So it's inches. It's like walking. I don't know if there's any circles around, but if you were to walk around the circle, it's still a length. And so it's whatever these units are. So this one is 70 centimeters when you do that.
Okay.
So 32 we'll do next. We're just do these in a certain order here for now. So this one is different. They give you it in degrees, which is no good because you need it to be in radians. So you have to convert that 18 to degrees. You multiply by pi over 180. And see how 18 goes into 180 really nicely. You get that. So your answer is S equals R theta. In this case, it's 5 times pi over 10. So notice it's just pi over 2 is your answer. But you really need it to be in the right units, feet, because that's in feet.
Okay.
Okay, let's go on to 27 and 28. '27 and 28. Okay, the S, R, and theta. So if S equals R theta, then R equals S over theta, but theta has to be in radians. So in 27, R is 1.5 divided by pi over 4. Now they want a nice answer, so you have to do a little bit of like remembering how to deal with decimals and fractions, or if you're allowed to use your calculator, just don't put the pi in. You have to put it in at the end. But this is 3 over 2 times the reciprocal of this 4 over pi. So this ends up being those cancels, ends up being 6 over pi feet, because the units have to match there. And for 28, again, it's R equals 2.5 over pi over 3. So 2.5 is 5 halves times, the reciprocal of that, 3 over pi. So this ends up being 15 over 2 pi centimeters. And it's okay to have this kind of what maybe appears to be not a nice answer, but you can always put it in your calculator if you really, really needed to.
Mm-hmm.
Okay, now 31. Yes, 31. So 31 is similar, except that they give you the angle in degrees. And if you don't hear me already saying it can't be in degrees, it needs to be in radians. S equals R theta, theta is in radians. So you're going to multiply by pi over 180. Pi over 180 is pi over 9 when this simplifies. So your R equals 40 over pi over 9. Yeah. So this equals 40 times 9 over pi, 360 over pi centimeters.
Okay.
And then the last two last pair here, and it's like I think for learning purposes, it's great to do these kind of like over the ones that are similar together, especially first time really will help here. S r theta. We know that S equals r theta, but theta is in radians. So theta is equal to S over R. Okay, so our theta in number 29, our theta is 3 over 1. And the answer here is 3 radians because theta is in radians. Well,
Mhm.
unless they tell you it's in degrees, you assume it's in radians, or it's got the degree symbol. 30 is theta is 4 over 7. But again, that's 4 over 7 radians. If they wanted it in degrees, you would do the conversion, but it doesn't say to do it in degrees.
Okay.
So as long as you say rad or radians, you're good. There's no issue there. 38. Okay, snip that in. The concentric circles on an archery target are 6 inches apart. The inner red circle. So let me draw it here. Okay. So here's this is the inner circle, and it has a perimeter of 37.7. So that's really the circumference. But then there's another concentric circle, which I assume is the outer one. And this is 6 right here. But this one down here, this has a circumference of 37.7. And they want the perimeter of this bigger circle here.
Okay.
Okay, so we're first looking at this little circle. Your formulas for circles are as follows: 2 pi r for circumference, or pi times diameter. You learn that in geometry. And the area of a circle is pi r squared. So they're giving you the circumference 37.7 equals 2 pi r. Your radius is 37.7 divided by 2 pi. If you're doing this calculator, make sure you put that in parentheses. So you divide by 2 pi and not divide by 2 and then multiply by pi.
Okay.
So if you get that down, let me know we get it caught up of it. The circumference, I'm sorry, the radius is 6 inches when you do that calculation. And I know it's inches because they're all inches, okay? So that's the radius of this one, this little circle here. The radius of the big circle is 6 plus the distance between them, which is also 6. So its radius, we might use a different R for that. It's 6 plus 6, which is 12 inches.
Okay.
So we want the perimeter, which is really the circumference of the other one. So the circumference is 2 pi times big R this time, which is 2 pi times 12. So it's 24 pi inches. You could multiply 24 times pi if you want. It's not necessary. It's up to you.
Okay. Got it.
They usually give you a word problem here. Almost every standardized college entrance exam, they ask you about finding the area of a sector or the pizza slice. Maybe that's upcoming in 44. I don't know. 44. Okay, so we got a nice, lovely word problem here. Okay. 44. Table 4.1 shows the size specification for the tires. Okay. Find the speed of each vehicle in miles per hour when the wheels are turning at 800 revolutions per minute. Okay, so 800 revolutions per minute means this right here. So if you've taken chemistry, you're familiar with these conversion problems. So we have to convert minutes. Well, we want to go to miles per hour.
Oh,
So
we
we
have
got
to do table thingy.
you. Well, yeah. So I'm going to make it simple here. In 1 minute, okay, there's 60 seconds, okay, and in 60 minutes, it's 1 hour. Wait, why is that in the wrong place?
You do. Oh wait.
I'm sorry. I went the wrong way. I'm sorry. So 1 minute, it should be this 60 minutes in 1 hour. There we go.
Yeah.
That's much better. And then we calculate revolution. So one revolution is 2 pi r, right? If you go all the way around the circle, that's 2 pi r. That's one revolution. That's the circumference. So you have to do the following for each of these calculations. It's 1600 pi times the radius. So this first one, because it's giving you the diameter, its radius is 13.6, 14.3, 14.5. Problem is that's not in miles. So that number is in inches. So we're gonna use that number in inches, okay? And then we need to do the conversion from inches to miles. So there's 12 inches in 1 foot, and there are 5,280 feet in 1 mile. So in short, I'll make this a little bit more compact here, is you're going to do 1600 pi over 12 times 5,280. And for each one of these, you're going to multiply by whatever that number is for the radius, because you have to do it for each of the wheels.
Okay.
Okay, so for the first one, I get, I don't like that. 12 inches in a foot, 500 feet in a mile. Maybe I didn't get this right.
I got 0.34 repeating.
Yeah, I got 1.08, but that doesn't seem very fast in miles per hour.
Yeah.
One revolution. Okay, so let's do this one. Oh, I didn't multiply by 60. There's the problem. Okay, so there's a 60 up top here and a 60 up top here. And again, like if you're doing this in your calculator, make sure you put all that in parentheses. That will now work out a little nicer here. Okay, so for the first one, I get, for this first one, it's 64.7. The next one is 68.1. And then 69.0 for the last one. Let me know if there's any issues with those calculations or if you're not getting the same ones.
Yeah, I got the first one's the same. Yeah.
Okay, perfect. So the next thing they're asking here is they're saying, compared to the Mercury Mariner, how many more revolutions must the tire of the Ford Taurus make in order to travel a mile? So we're looking at the last two here, the Mercury Mariner, I'm sorry, the first one, the last one. Okay, so one revolution, let me do it down here. So for the, let me go back. Actually, I'm gonna look at this on the other screen. So I got it. For the Ford Taurus, one revolution is 2 pi times 13.6 inches. And we know that we have to convert that. So there's 12 inches in 1 foot, and there's 5,280 feet in 1 mile. Okay. And then if we do the same thing for the Mercury Mariner, one revolution, it's the same calculation, 2 pi, but this time it's 14.5 inches. Okay. And times 1 foot over 12 inches times 1 mile is 5,280 feet. So what this is going to tell us, we need to get this number. Whatever this number is, this is how far it goes in 1 revolution in terms of a mile. So we're gonna get that top number. Then hopefully it also makes sense. It's 2 times pi times 13.6 divided by 12 divided by 5,280. So you get a pretty solid decimal. You get 0.0013. All right. And then this other one, the Mercury, it's going to be slightly bigger than this. It's still not very big, but it's going to be 14.5 is the only number we're going to change in there. So it's 0.0014. So in 1 revolution, it goes this far. In 1 revolution, it goes this far. We really want it to go a mile. We really want this number to go to 1. So if you take this number, or 1 divided by that number, and 1 divided by that number, you will see the difference between them. So 1 over 0.0013 means that it has to go about 769 revolutions to get 1 mile. And then 0.0014, you see it's slightly less. It's approximately 714 revolutions. So if you were to multiply this number 0.0013 by 769, it'll be basically 1. And similarly down here, so you can see that the Mariner needs to obviously go more. It needs to go about whatever the difference is in these, like 55 more revolutions.
Okay.
So maybe you know this, maybe you don't. When you put bigger tires, or smaller tires for that matter, on your vehicle, you have to recalibrate the speedometer.
Mhm.
And it's because the larger or smaller tires, they don't give a true story of how far you've gone because of what we just talked about here.
Oh,
And that's what it's asking about here. You can just do a quick Google search on that also
okay.
if that's not clear. But let's move on to page 347, number 2. We spent a lot of time on those problems, and I'm sure these are also unclear. That's interesting. Identify one angle that is not coterminal with the other. Okay. All right, so we're starting a new, completely new section here. Okay, so it's coterminal, and it's easier when it's in degrees, but it's coterminal when you add or subtract 2 pi. And it's easier when it's in degrees because you add or subtract 360. Okay. So because they're all over 3, you're really adding or subtracting 6 pi over 3, because that's 2 pi. So it's like, what is 5 pi over 3 minus 6 pi over 3? It's negative 1 pi over 3. And what is 5 pi over 3 plus 6 pi over 3? That's 11 pi over 3. So see how this one and this one for sure are coterminal, the first and third, because
Yeah.
that shows up there. Now you can actually keep adding and subtracting. So like here, if we subtract 6 pi over 3, we get minus 7 pi over 3. There we go. We got another one. That's great. This one you have to keep adding 6 pi over 3 plus 6 pi over 3, and so on. But it sure looks like this minus 5 pi over 3 is the one that is not coterminal.
Okay.
So the typical question on the test is not to determine which one is not. It says, determine a positive and negative coterminal angle. All right, number 4. Okay, so you got to find the value of the 6 trigonometric functions. So the first one is sine. And how much of this do you remember from previous classes?
We've gone over it already, so I know like all of the
Okay.
6.
Okay, so sine is you need the hypotenuse here, which is not given. So I would actually have you draw the triangle here. That's a horrible drawing. 4 minus 3, and that's 5. The hypotenuse is always positive. Okay, and there's your angle theta. So your theta is minus 3/5. Cosine theta is adjacent over hypotenuse, that's 4/5. And there's a specific order. There's a specific order here to do this. Like tangent is sine over cosine, which is minus 3 over 4. And then cosecant theta is the reciprocal of this, minus 5/3. Secant theta is 5/4. And then cotangent theta is the reciprocal of this one, minus 4/3. So there's kind of like a mapping if you want to do that. All right. What's the next one here? 8.
8.
So it's kind of the same thing. They don't give you the graph this time. So 8 is the point minus 4 comma minus 6. So if you were to graph that, you would get a point over here. This is minus 4, minus 6. And then the hypotenuse is the square root of that squared, 36 plus that squared, 52, 16, which gives you 52. So that's 2 square root 13. Yeah, so now, here's your theta. So sine theta is minus 6 over the square root of 13, but you're probably going to need to rationalize.
Yeah.
So that's the square root of 13 over the square root of 13. So minus 6 square root of 13 over 13. And then cosine theta is going to be minus 4 over square root of, oops, I didn't put the 2 in. That's really bad. That actually does affect this. It becomes 3 up here. So that's negative 2 over square root of 13, multiply top and bottom by square root of 13, negative 2 square root of 13 over 13.
Okay.
All right, now the tangent of theta. So this is where it's sine over cosine, but it's easier just to go back to the triangle. It's y over x. It's minus 6 over minus 4, which is 3/2. All right, so the next one is cosecant theta. So you can flip any of these, but it's probably better to flip like one of these up here that's not rationalized yet. So it would look like 2 square root 13 over negative 6, or negative square root 13 over 3. And then secant theta, you can flip this is a flip of this. So 2 square root 13 over -4. So it's negative square root 13 over 2. And cotangent theta is the reciprocal of this last one, 2/3. That's kind of your test question.
Yeah. Okay. 10 is next. It's just the same thing.
Okay, -3, 0. So this one is on the unit circle, which is, I guess, a little different.
Yeah.
So if we were to graph it, it's over here. So this is where maybe it's better to use like like sometimes students are like, okay, sine is x, sine of theta is x over h or r or r. Are you doing that at all?
Yeah.
And cosine theta is, well, actually that's y, is like x over r. That's where this, like your r in this case ends up being the square root of -3 squared plus 0 squared. So your r ends up being 3.
Okay.
So our cosine, let's just, so your sine theta is going to be 0 over 3, which is 0. Your cosine theta is -3 over 3, which is -1. Your tangent of theta, it's either sine over cosine or y over x. In this case, 0 over -3 is 0. And this is where we run into this problem. So cosecant of theta is the reciprocal of this. It's 3 over 0, but that's undefined. Secant of theta is the reciprocal of this. So it's 1 over -1. So it still ends up being -1. Cotangent of theta is -3 over 0, the reciprocal is 0, so it's undefined. And that's normal. Whenever you're on one of these places, yeah, it's undefined.
Mhm.
And some of them are undefined, not all, but some are. That's the important thing there. Okay, 22. No. It's a weird question. It's multiple choice. So and if you have a unit circle, you would just grab it and answer this, but we'll try and show you how to do it if you don't have a unit circle. So here is kind of the upper half. This is pi over 3 right here. And then 2 pi over 3 is like the same height.
Yeah.
It's 2 pi over 3. So whatever's going on here, you have matching values here. So if you can remember that this is 1/2 comma square root of 3 over 2, over here, it's just -1/2 comma square root of 3 over 2.
Mhm.
That gives you the answers here, kind of here. So they're using a slightly different triangle, but is it just A, B, and C?
Yeah.
Okay. So the one that's like closest is negative, positive on that. Okay. Now we can actually get the full values here. So if your triangle is like this, if this is -1 and this is the square root of 3, okay, the this over here becomes this becomes the square root of 3 squared plus -1 squared, this hypotenuse, square root of 4, which is 2. So it ends up being 2 there. And that's how we got these points, but that's how these still work.
Yeah.
Okay. That takes care of that one. 24. Oh, you got to do another one. All right. Have you done a unit circle quiz yet in this class?
Not yet. If we have some time at the end, maybe we can review the unit circle because I
Okay.
am rusty.
It's tough. Yeah, you gotta get it down. It comes back over and over again in other classes if you keep taking math. So
Unfortunately.
yeah. So 60 degrees 60 degrees is that pi over 3. That 60 degrees is right there. So minus 60 is down here.
Mm-hmm.
You got it. That's how you do this with symmetries to like learn it. That's how you learn your unit circle. This is 1/2 square root of 3 over 2. And so this right here is 1/2 comma minus square root of 3 over 2, because it's obviously going down. So you just match the one that seems to most closely match that, which it's that one there. You can make the triangle if you want to kind of like verify that. That's 1, and that's minus square root of 3, and you get 2 there. Same thing,
Mm-hmm. Okay, 44.
44. Find cosine theta and cotangent theta if sine theta equals 1/4 and tangent theta is less than 1. So there's this mnemonic ASTC. Have you seen this before?
Mm-hmm.
Okay, so it stands for all students take calculus. At least that's the appropriate version of it. And A means that they're all positive. So sine, cosine, and tangent are positive. But you know that like cosecant is really like sine, and it's also positive, and secant's like cosine, so it's also positive, and cotangent's like tangent. Where the power of this is over here in these other ones. This means that sine is positive and the rest are negative. But because sine is like cosecant, it also applies to cosecant. Sine is positive, the rest are negative. Tangent is positive, the rest are negative. Cosine is positive, the rest are negative. Why does that matter? Well, they're telling you that tangent is less than 0. So tangent is negative here and here. Why is it up here? Because sine is positive and everything else is negative. Tangent is everything else. Similarly, cosine is negative. So cosine is positive, so tangent is negative. So they're right there. So now we got to figure out, well, okay, well, where is sine positive? Which quadrant is sine positive in? Well, it's right here. So whenever you're doing these problems where they give you two things, there's only one quadrant where you get the overlap.
Mm-hmm.
The next thing is that there's what I call the reference bow tie. There's only 4 triangles that you'll have. And depending on which quadrant, you just have to draw the right one. So you remember what a bow tie looks like. You get that one there. Boy, that's horrible. Let's get the little better drawing of that. Okay, so here's your theta. Sine of theta means opposite over hypotenuse, like that. So we're in the second quadrant here. So this side is negative because it's the square root of 4 squared, 16, minus 1 squared, 15. But it's negative because to get to this top position here, you have to go left, which is negative, and then up, which is positive.
Mm-hmm.
So now that you've got your 3 sides of your triangle, you can find anything they want. Now they want cosine of theta. Cosine of theta is minus square root of 15 over 4, adjacent over hypotenuse.
How do you get root 15 for the?
So we're going with A, B, C. A squared plus B squared equals C squared. In your problem, you were given B is 1 squared, C is 4 squared.
Oh, okay.
Yeah, you got to be able to find that. You're going to do it in a lot of problems here. Cotangent of theta. So tangent is normally opposite over adjacent. So the cotangent is the flip of that, minus square root of 15 over 1.
Are we on like the wrong screen right now?
I'm sorry. Maybe it, I don't know. Did something change?
Yeah.
Okay. I know what it changed to, but forgive that. I hit something with my mouse and then I didn't realize it changed. So, oh, I see. You are on a different, yeah, sorry about that. There we are.
Yeah. Okay, next one is 55.
Okay, 55. All right, 55. This is called Snell's law, which you might see in physics if you ever take physics or care. So they're just giving you the numbers here. They're giving you theta 1 and theta 2. So it's the sine of 83 equals mu, the sine of 36. Now these are in degrees, and you want to make sure your mode in your calculator is in degrees. It's very important to always think about that when you're doing a calculation, because you can get the wrong number, and it might even appear right. You just there's no context. So here they're just asking you to solve for mu. Mu is the sine of 83 over the sine of 36.
Okay.
So let me get that number also for you.
Yeah, 1.69.
Yeah, that sounds right. Yep, 1.69. There's no units. It's just whatever number you come up with. And the idea is that for different materials that light would go through, there's different values of n.
Okay.
Make a sketch, it will help. Okay, 59. I was looking at a different question.
Yeah, we did.
All right, so 59, is that our last one for this section?
It is.
Okay, so another kind of multi-part question. Then, okay. Right, so it says here, get a little smaller picture. It says that the airplane is 8,000 feet, but the vacationers are already hiking, so it's only 600 feet above them.
Okay.
All right, and then it says the angle of elevation, which is right here. Here's the angle of elevation, which happens to be the same as the angle of depression. Okay, these are the same. Is given as theta, and they say find the distance from the group to the jet for the given angle. So I guess it's they want you to find x. I don't know, that's weird. Flying over altitude, the angle of elevation of hikers. Yes. Okay. Yes, this is right. So x, the tangent of theta equals 600 over x, and that's just from SOHCAHTOA.
Mhm.
You know that. X is then 600 over the tangent of theta, and then you can you can do this for the different values. So like part A, you're going to do 600 over the tangent of 45 degrees. Part B is going to be 600 over the tangent of 90 degrees, which I don't think which you don't think this last one's weird because tangent of 140.
140.
Yeah, I don't know. It's like it's above them. I don't know.
Like, how can it be that doesn't make
Yeah,
any
I don't
sense
know.
in regards to the question, but
Maybe my picture's wrong. I couldn't say for sure. I mean, I don't have like a ton of confidence in this. I just know that what I have isn't great here.
okay, so and I should still be in degree mode, right? That's fine.
Yes.
Okay, well, A is 40 or A is 1 or
Yeah,
no.
Yep.
Well, the tangent of 45 is 1. So it's just 600.
yes. But and the thing is 90 is the tangent of 90 is undefined.
Yeah.
So I'm not even sure what you're supposed to do there. I don't know. It's probably one of these questions where the instructor's just like, oh, this will be fun. We'll do this question. And or you get into it and you're like, oh, this doesn't really help. Um,
And it isn't really fun.
no, it's not fun. All right. I'm gonna send you. Do you have a unit circle? I can send you a quick trig reference sheet if you don't have one. Do you have,
Yeah, I don't have one on hand.
we're at the end of our lesson, but this is a good one to like print out. It's page 3 and like stare at it, pretend like it's exciting.
Okay.
And then that's really the only way to learn this is to look at one, and then you want to do a Google search for a blank unit circle. That might help you.
Oh yeah, okay. I remember your cheat sheet from last year.
All right, well, that does take us to the end of our lesson for today. Thank you so much for scheduling, and I will see you next time.
Okay, sounds good. Thanks, Matt.
You're welcome. Bye now.